So in talking about dimensions, why do we have them on the plans? And I just abbreviate dims or dimensions as dims all the time, so that's what I mean when you see dims. Why do we have dimensions on plans? Got to know the size to make it, right? Now, dimensions are broken out into a couple of different formats. First of all, if I give you a block of wood and I put a hole in it, you need to know a couple things, right? You need to know, what about the wood? What size? So I need to show you things like, all right, here to here is a dimension, here to here is a dimension. What else do you need to know about the block of wood? Height needs to be provided. I'll just show it off here. Some height is given. Then I need to tell you a little bit about this hole, right? So I probably need to give you what value? Diameter. And then I need to give you something else. What? Location. So we've got, and of course for the hole it's going to be to the center, and etc., etc. Now, to break it down, we have two different forms of dimensions here. This one is different than this one. What kind of dimension would you call this one? What's its purpose in life to do? That's true, but not so specific. Be more vague. It's a size dimension, right? It tells you the size of the part. It happens to be the length for sure, but it's the size of the part. Agreed? Now, is this dimension a size dimension?
No.
It is not. What kind is it?
Okay.
It's a location. It tells you where to locate something, which makes total sense. Dimensions are broken down into those different formats. Now, does it matter to you on a plan whether you're dealing with a size or location? Not really, but it is important to keep track of what something is describing so you don't make a mistake. For example, people often start to miss features on drawings because they get to pay attention to the wrong type of dimension. For example, I've seen a lot of folks, let's see if I can convey it more accurately. I've seen a lot of folks do this. Let's say this is 3 and this is 0.5, okay? And I will ask them how tall this notch goes into the part. What will they tell me, you think? They'll say 0.5. Why? It's because it's just, for some reason, starting off, it just flows through their mind that this hole is for some reason 0.5 by 0.5. They'll just assume it is. It's not. It could be 1, it could be 0.1, it could be 0.75, who knows? You have to pay attention a lot of times to these features of the dimensions more than anything else. You know, people like to look at the numbers, but it's these legs that really you have to hone in on. Why is that?
Because it's that line that you're...
These are your directions. These show you what you're touching or what you're talking about. So for example, this 0.75's lines are pointing to this point and this point. So people have a hard time with that when they first start off in this process. They misinterpret a lot of things because they just skim through it. They'll typically only look at the horizontal dimensions and they'll miss stuff that's showing in a different direction. So for example, if I give you this dimension, I'm talking about the point from here to here. Agreed? Let's say it's 2. If I turn around and give you this dimension, what's it going to be? 2. It's the same alignment. However, if I turn around and give you this dimension, it could be something else, right? Those dimension extension lines, so those features of the line, the leader lines, are actually what you need to really pay attention to. The distance between them is pretty straightforward. But these are your targeters. You look at those to figure out what you're lining up to. By the way, when you look at a set of drawings, you are not actually, in reality, measuring this line. For example, if I give you the distance from here to here, and let's say it's 15, I'm actually not telling you the value of this line. Inadvertently, it's the same. But what I'm actually telling you is from this point on the drawing to this point on the drawing, the value is what? 15. It just so happens that this line is a perfect vertical. Here, let me give you an example. Here's a common mistake people make. This is line A. How long is line A?
Longer than 15.
Longer than 15. Why?
Because it's at an angle.
Right. See what I'm saying? The dimension does not actually tell you anything about the line. It tells you what the distance from one point is to another point on some kind of plane. Now in this case, it would have been the same if this plane was here or down here. Anywhere along this distance and along this plane, that was a bad version, along this plane is a value of 15. So if there happened to be a circle that lined up with this, right there, what would be the distance from here to this line? 15. That's one thing to keep in mind when you're looking at a set of plans. You're not actually looking at dimensions that measure lines. You're looking at dimensions that measure a point to point. Now, if I want to show you how big A is, here's what I would do. I would do an aligned dimension. Let's just say it's 15.5. I don't know. An aligned dimension would tell you that anywhere on this point to this point is 15, and since line A is parallel to those two planes, its value is 15.5. Okay, see the difference? It's a very common mistake early on in drawings is that people misinterpret that kind of thing a lot. So you got to watch out for it. And actually that's one of the most common things that happen. So you kind of get your mind away from that and you're doing good. Now, another case in point. Here's a part. It's got a lot of features going on here. And I give you a choice. I can dimension this thing this way from one spot to the next. Or I can dimension it this way. And all the way to the end. Alright, this is option A for dimensioning style, this is option B for dimensioning style. Which one do you like better?
A is more simple.
A is simple. A is used a lot in construction. A lot. So, I asked that question first. A is simple, easy to read, you can do that, right? But, which one has the least amount of actual error if it's used? Why? Explain why that's the case. You say B, but why is B less error? They'll have technically the theoretically same numbers, but tell me why B is going to be better in terms of error.
Oh, having the overall?
Well, you have the overall, but that's not why it makes it better. Think about, go ahead, what? That's true. Think about if I'm off on one of my measurements. What happens in A?
A is more, I guess you call it absolute, no, it's incremental.
It's increment, that's true.
But, or A is incremental and B is more absolute, so if one measurement's off of B, your next one will still be right.
Absolutely. If you make a mistake on this one in B, does that affect this one or this one? No. You make a mistake on this one in A, what happens to these two? They're off. Right. So what we find in design and blueprints is that in fabrication, so to speak, we will use this. B is the better format because B allows us to make a mistake measuring it out or laying it out on a table and not throw the rest of the thing off. So if you use B format to dimension, you don't compound errors. In A format, you make a mistake here, it makes this off and everything downstream off. Now the reason we use in construction a lot more, A format I'm speaking of, is because big objects, big buildings, those kind of things, walls and doors and stuff like that, they can stand to be an inch or two off and it's hard to measure through a wall. So if this were a floor plan, it would be hard for me to go build the walls on the inside of the building when I'm measuring from one point outside. So we do use this format for construction of building. But for fabrication and parts, this format gives us less problems. Yep.
Oh. I don't debate what you're saying.
Yep.
The only thing just to help me to understand.
Yep.
Whether I measure from here or here, if this is supposed to be 3 feet,
Yep.
it has to be 3 feet either way.
That's right. That's actually a very good point. So theoretically, and that's why I use the word theoretically, both A and B result in the exact same measurement. Okay? They are identical. But we're talking about what happens in the real world when you come out and can you perfectly lay out 3 feet here? In reality, perfectly? No. You can't perfectly lay out 3 feet. You go fine enough, you'll be off some. Now, in measuring tape wise, yes, you can hit 3 feet. But think about a quarter of an inch, an eighth of an inch, or 16th of an inch, 32nd of an inch. Are you going to hit it perfectly? No. Nothing can. No, not even our most advanced equipment can fabricate things. And we're talking, let's think small parts. Not our most advanced equipment can hit a perfect absolute value. There's always a level of error. Agreed? Your cutting torch is going to leave a little error, right? It's small, beyond the human eye to see for sure. But if I'm off a 16th on the first one, does that throw this next one off? It does. Huh? On B, no. On A, though, if I'm off, even if I'm off a 32nd on the first one, does it throw off the next one? Does it throw off the next one? And so on and so forth. So the reality is, on the paper, yes, it works. But if you give somebody the ability, like let's say we're not building a house, let's say we're actually laying out a sheet of steel, and we're talking about something that is, I don't know, 6 or 7 inches in size. But it's going to be in a tight fit place, right? And they get out their tape and they make a little mistake right here, not much, but just a little. Will that affect any of the other dimensions? In B format.
They can go ahead and proceed on B to do the rest of it and then go back and fix their error for A.
Right. And they may not even know
You have to fix the first part first and then go.
Right. You're going to have to use B to deal with fabrication. Yep.
And to further, with what you're saying there. And I see what you're meaning, as if they made a mistake here.
Yep.
We can still correct on that part, but there's a part of that too. If this mistake is made, if this is too short, we can never put it back. If they make a mistake and go too long, then we can mill this or whatever and bring it back.
Well, that's true, but that's a little bit beyond the scope of what we're talking about right now. But you're absolutely right. Now, we're just talking about the blueprint side. So the reason I've asked these questions for you is not because, you'll be laying out some blueprints as part of the coursework or, kind of getting a feel for that. But it doesn't mean that you're going to be doing this on a regular basis. The key thing is you need to understand why drawings are going to be laid out this way versus this way. It depends on the field of fabrication. If you're doing big structural steel, you'll probably lay out in A. If you're doing fine-tune work where air really, really, really matters, you're going to lay out in B. And it's important for you to understand because the next several topics are going to rely on this. This one, this B format, uses something we refer to as a datum. And that's going to come up a lot. A datum is a plane of reference. So in the case of B here, let's simplify our part. If I measure from here to here, and then I measure from here to here, that means that this surface is a datum because I'm basing other features off of it. Agreed? Now, if I measure from here to here, and I measure from here to here in our other format, then yes, this surface is a datum, but also this one turns out to be a datum, and it can't really be a datum because it's not a fixed point. So this other factor falls into a little thing we like to refer to as QC, which is what? Quality control. Huge deal in industry. Quality control makes or breaks companies. Why? Exactly. If you don't have a QC department checking your work before it goes out the door and stopping errors, you're going to have a very short string of clients, because quality control means that thing doesn't kick back, shipped, and money lost. So quality control is highly interested in a dimension scheme that keeps people from making mistakes, or better way of saying it, minimizes potential for mistakes. If I have the choice to lay it out for you in this datum dimensioning format, I'm going to do it, because that way your chance of laying out a part incorrectly is reduced. If I give it to you this way, you can make a mistake there, you can make a mistake here, you can make a mistake here, and every time you make one of those mistakes, it makes everything else even worse. It's not about correcting. Right now we're just talking about the plans themselves. But it's going to factor in later on, because quality control is a huge deal. Okay? We get sent to train companies on quality control, specifically this particular thing, all the time, because this is where the money is. You can get a contract to build a bunch of stuff, but you start losing money real fast when you have to kick stuff back, especially if it gets out the door and the client finds it. Then there's all kinds of problems. If you catch it internally, that's good. If you find ways to minimize the quality control issues by changing your dimension style, save more money. Case in point, I was at a company a couple weeks ago actually, that they just found, while we were giving the training, they just found out that they had shipped a batch of bad parts that hadn't been stamped correctly, and it was a panic day, because they had gotten through QC, got out the door, been shipped on the way to the customer, and they were about to hear about it. So money to be lost, because all that either has to be destroyed, shipped back and fixed, and that interrupts the flow of work all day. Just creates a huge cost loss or profit loss because of that. So that's why we're talking about dimensions, and why your layout of dimensions is important. And let's think about it. If you're dealing with a part that's about the size of your thumbnail, every little micron matters. So QC is going to want dimensions that actually help to remove that. Now, if you're cutting with a handheld torch, you're probably not going to be super high interested in precision work, but you still have a level of tolerance you have to hit, and we'll get into tolerances coming up too. So, questions on that? The takeaway is, there's a reason why sometimes we dimension from spot to spot in these chain formats, and there's a reason why we use these datum dimensioning formats. And each industry makes the choice based on their practice and how comfortable they are with error. How much they can live with it is what it boils down to. Okay? Alright, so with dimensions, you're going to be dealing with just format. Watch out for the mistakes that are common. Always watch those dimension legs, if you will. Watch what they're pointing to, and understand, most importantly, when a dimension's given to you, you are not measuring lines. You are measuring the distance between two planes. So when you get a notch like this, it is in fact not, when they give you a dimension just like this, you are not measuring the line. So if it says 2, and you try to lay out a 2-unit line, what's going to happen right here? It's going to be short. Well, I mean, technically, the line, if you actually made it out where you just drew lines on paper, it'd be 2. But you wouldn't be able to measure. You can't slick this down and say, oh, this is a 2-unit line. We're going to come up wrong. Absolutely. Absolutely. That's an excellent question. How do you calculate this? How would you figure this out? Here's the best part about dimensions. The designer is going to give you enough information to make it without trying to be too redundant. So what they're going to do is they're going to provide you this dimension, and then they're also going to provide you this dimension. So then at that point, do you need to know the length of the line? No. You know where this point is, you come over so much, you go down so much, you know this point is, and you connect the dots. Technically, a line is nothing more but the distance between 2 points, so it's not the line that you're actually laying out, it's the corners that you're laying out. They may also do this. However, do I need to know that right now? Do I need to know that 30 degrees to make this line, if I have the dimensions?
No.
I do not. In fact, you want to avoid, if you're fabricating, you want to avoid trying to work off angles. Why?
Too much chance of error.
Too much chance of error, absolutely. Your ability to lay out angles is a lot more challenging than just coming over a certain distance, going down a certain distance, hitting 2 points, and drawing a line between the two. When you start having to get out tools to do angles, you're much more likely to have mistakes. Now, don't get me wrong, you throw out a T-square on a 45, that's not too much of a big deal. But when you get into, not everything's 45 degrees. So, on a set of plans, yes, they might give you this, but if they give you these, that's the way to go, for sure. And hopefully a good designer will know that and will try to avoid potential mistakes. It's all, at the end of the day, it's all about the quality control more than anything else. All right, any questions? All right, so there's some of your game plans, and I'll let you go ahead and get started with some of the material and go from there.